Sample space is the set of all possible outcomes or results of the experiment. Sample space and the fundamental counting principle go hand in hand. If my first experiment is flipping a coin and rolling a die. You'll remember from the fundamental counting principle that and is multiplication. So when I'm flipping a coin, there is exactly two outcomes, heads or tails. All right, so there's two outcomes. When I'm rolling a die, there are six outcomes. I could roll a 1, a 2, a 3, a 4, a 5, or a 6. So there are 6 outcomes. So the total number of outcomes is 2 times 6, which is 12 possible outcomes. If I wanted to know what the outcomes were, this is when I would make a tree like I did at the beginning of the counting principle. So still sticking with the flipping a coin and rolling a die, if I flip my coin, I could have heads or I could have tails. All right, when I roll the die, I could have a 1, a 2, a 3, a 4, a 5, and a 6. And if I'm flipping flipping a tails, 1, 2, 3, 4, 5, and 6 down here. So if I look at it, now I messed up drawing my tree a little bit, but if I follow a branch, that tells me outcomes. I could flip a heads and roll a 1. I could flip a tails and roll a 6. All right, so there's multiple different outcomes, but there's 12 total, and I would have to do a tree to find out what each outcome is. My second example is a little bit different. Instead of having 2 events that are taking place, we're looking at one event, which is choosing a sports player, athlete. There we go, that's the word I was looking for. If there are 10 basketball players, 25 baseball players, and 4 that are on both teams, what is the sample space? In this case, we have 4 people that are already in both groups. So we're gonna use a Venn diagram to help me set this up. So when I'm setting it up, there is some overlap between the 2 sports. So if this is basketball and this is baseball, all right, there's an overlap between the 2, and that overlap is 4. So when we're trying to figure out the sample space, basketball has 10 people. We've already counted for 4 of them. That means there are 6 more. When I look at baseball, there's 25. We've already counted for 4 of them, so there's 21 more. So when I set this up, that gives me a total of 31 people. If I look at my original problem, if I just added them all together, that would be 35, 39 people. All right, this 4 people would be counted twice, or these 4 people would be counted twice. We don't want to count them twice. We want to make sure that everybody's counted 1 time. 2 fish are in a tank. One looks at the other one and says, how do you drive this thing? My third example is similar to the last one. What is the sample space if there are 15 basketball players, 61 football players, and 7 that are on both teams? So once again, we have 7 people that are on both teams, so there's an overlap of basketball and football players. So if this is basketball and this is football, the overlap is 7 players. All right. The number of basketball players, there's 15 total. 7 have already been used. There are 8 left. For the football players, there are 7 have been used, so there would be 54 left. If I add up these numbers, I end up with 69 total people to choose from. So instead of my sample space being 15 plus 61 plus 7, my sample space is 8 plus 7 plus 54, 69, so I don't count these 7 people twice.